My topic is actually wide area tracking and industrial applications, including social media. Just for background briefly, I come from Finland. VTT is the third largest research center in Europe with some over 2,000 employees. And we have a team of AR and 3D tracking research of some 15 people in Espoo, south in Finland. We do provide both technology and applications. So mostly we do project work, but along the side we are developing our own SDK called Alvar. We've been working on various application areas, starting from games and entertainment already 15 years ago, then consumer applications and so on. But recently, all our work is going to industrial applications such as maintenance, assembly and training. Also architectural applications, or more generally AEC applications. The most recent application area is in indoor industrial facility asset management kind of applications. For a tracking example, could you click on the image to start the video? So, is it looking for the videos from the internet or locally? Okay, that's a YouTube page. So this is an example of how we did tracking a few years ago with an outdoor example of adding a new part in an oil refinery. And here we are using the SLAM approach, and that requires some initialization steps, which we did in the, as you saw, the user shows some corresponding points between CAD model and the image. After that, we are able to start looking for feature points in real-time video, and we get this very accurate tracking as you see. So maybe stop the video and go to next slide. Next slide, please. That's not my slide. So while we are waiting. So, okay. That video was done a few years ago. How we work nowadays, we prefer to work with 3D point clouds, which we create as a pre-processing step before we start tracking. How we do that is take a bunch of images from the target. Then we use some well-known third-party software like Visual SFM to create the point clouds. And after that, when the user enters the space where we created the point clouds, we have automatic, very efficient tracking. If you click on the below image, we should see an example again. Hello? So I was supposed to have these videos locally on the PC, but we didn't find the connection to use it. Can you click on the below image, and that should get us to the YouTube. Okay, so please start the video then. So what you see here is on the right we see a floor plan of our cafeteria in Finland, and on the left we see augmented instructions. The user wants to find some food items from the vending machines, and the system is showing with red arrows and annotations which buttons to click on the on the augmented image. In this case, we actually have several point clouds, so the system automatically detects that it has to load a new point cloud and then switches between the point clouds. We can have the point clouds on local servers or even edge computing servers. As you see, everything happens without any delay and with very high accuracy. I don't know if you can see the accuracy on this video, but there are some augmentations on the left side anyhow. These are the photos that we use to create the point clouds. And if the environment changes, let's say overnight, we also built a robot which could scan this environment, let's say, by daily basis and update the point clouds accordingly. Other ways we are currently investigating and implementing is that we would actually use the photos from the user device. So when people use the application, they by default take photos of the environment, and we are now developing a system where we use the user-taken photos to update the point clouds whenever needed. So next slide, please. Yeah, next slide, please. So maybe I skip some videos, but just explain a couple of applications where we are using these tools. So let's say on the below image you see a maintenance scenario. So there's a maintenance person with a tablet device. He's looking at the room and getting seeing on his tablet that the projector lamps needs changing and one of the loudspeakers is broken. How we achieve this is we align the point clouds with the BIM model of the building or the rooms in the building. We can also link whatever other information sources like facility management system in with the BIM model, and then have access to all this information on the mobile device, and not just able to see the maintenance targets, but click on them and open them up, write reports, and give feedback to the underlying systems. On the upper image, if you click on the upper image, we'll see a case of renovation application. Can you click on the upper? That one, yes. So here we have integrated the point cloud tracking and BIM models with VisiLean system by Aalto University. It's a system that where you can define lean construction processes, sprints, and so on to construction workers based on the BIM model. So you see the work tasks related to the BIM, which you see here. So this is the sort of normal VisiLean system user interface with the tasks and the BIM. And what we did in this case was to add an augmented reality feature to the system, so you would have all the same information that you have at the office available at the construction site, or in this case, renovation site. You will see the building information model elements in the augmented view and be able to also get all the lean process information on the mobile device. Again, all this based on point cloud representations of the room. So next, if you end this video, next slide, please. Just end the video and go to next. Most recently, we've been working with social media applications. So we've done an app where you can, by taking a photo of any object, let's say in the world, you can assign a hashtag to the object, and then as other users detect the same object, they will the object will be recognized, and you can have a social media discussion by tweets around this object. This is not the first time in the world someone is doing this, but what is special in our case is we are now investigating how to apply this in industrial applications, not let's say consumers tweeting around CD or DVDs and other Amazon objects, but maintenance people around the world attaching tweets to maintenance targets, and thereby having a new kind of platform how to collect the so-called tacit information. And last slide, please. So this technology is available as the so-called ALVAR tracking SDK. It stands for a library for virtual and augmented reality. It has all the 2D features like marker, multi-marker, image tracking, and then these 3D features I've been explaining about, running on all possible platforms that you can think of. How long do we have still? Okay, so thank you.